install, service, or repair electrical equipment? If so, this video was prepared for you as a reminder of the risks and dangers associated with working on energized electrical equipment. Turn off the power. That sounds like some pretty basic advice. But even if you are a veteran electrician or maintenance person, you can't afford to overlook or disregard certain risks or dangers that are present when working on or around equipment that is energized. The fact is, electricity can kill. To make our point, you are about to see a series of short-circuit tests that were conducted on 3 fusible switches in a test lab. The tests show the extent of what can happen when electrical equipment is subjected to phase-to-ground or phase-to-phase arcing. When situations like those you're about to see occur on the job, they can result in severe and often fatal explosions, fire, and electric shocks. As you watch, keep in mind how easy it is for these types of situations to occur. A fish tape comes into contact with live parts. A fuse blade or ferrule touches a grounded part or an adjacent phase. Or a tool gets dropped or is used in a way that closes the air gap between live parts or live and grounded parts. The result of these and other similar occurrences can be tragic. As evidence, let's take a look at exactly what could happen when such occurrences take place. In the following 3 test sequences, the voltage system is a 480Y 277-volt 3-phase 4-wire system with an available fault current of 25,000 amperes. The switches used in each case were 3-pole, 600-volt maximum devices rated at 100 amperes. 2 cameras were used to film the test sequences, one shooting at a normal speed of 24 frames per second, and the other at 4,500 frames a second to provide a slow motion view of what happens. For all 3 tests, a conductive link was placed in the switch to simulate a phase-to-ground contact. This link permitted the current to follow an alternate abnormal path when power to the switch was turned on. By definition, this is an electrical fault. In the upcoming scene, a phase-to-ground arc will take place. The phase-to-ground arc then virtually instantaneously escalates into phase-to-phase arcing with explosive force. First, we'll take a look at what happens in real time when the power is switched on. Now let's take a look at the same event in slow motion. Note the arc developing at the upper corner of the unit and the ionized gases rolling outward. In a matter of milliseconds, this escalates from a phase-to-ground arc to phase-to-phase arcing. The temperature of the ionized gas and arc is several thousand degrees Fahrenheit, hotter than the surface of the sun. You also can clearly see molten particles of copper, steel, and insulating material being expelled from the unit. The events in the first test lasted a total of 14 cycles. That's a little less than 1/4 of a second, less than the 1/4 of a second that has been recorded as the average normal human reaction time. Also, less than the time needed for ground fault protection to open a circuit, based on the ground fault trip settings applicable to most electrical systems. So if an event like this occurs, it's too late for the person working on the equipment to do anything about it. Now for the second test. This test is identical to the first, except that it lasts only 1 cycle. That's 17 thousandths of a second. Let's see what happens when the power is turned on. First, the real-time version. Now, a frame-by-frame replay of the same shot. In this case, the metal shorting link was blown away from the side of the enclosure, and all 3 phases became involved. Remember, all within 17 1/1000ths of a second. Our last test again involved an identical setup. Here, however, the fault lasted a little longer, 18 cycles. In the slow motion sequence, the shorting link is expelled from the switch, And the interior bussing behind the switch becomes involved, as evident by the major arcing that takes place. Remember, these were carefully controlled test sequences. Each began with a phase-to-ground fault that can occur when you work on electrical equipment that is hot. Each of these events involved phase-to-phase arcing, explosions, and the expulsion of ionized gases and molten metal. While the manner in which each event unfolded was a little different, you saw in no uncertain terms what can happen to equipment in such situations. We'll leave to your own imagination the possible effect on any people working on or standing near the equipment. But suffice it to say that these situations are extremely serious and potentially life-threatening. These events and others like them can occur anytime under working conditions involving energized electrical equipment. They all can be avoided by simply making sure the power is turned off upstream and the de-energized circuit is properly locked out and tagged out. But even after you have locked out and tagged out a circuit, never assume the power is off. Always test with a correctly rated voltage sensing device, and be sure to test the tester. Connect it to a circuit that you know is energized to make sure it's working properly. Then use it to check the equipment that is supposed to be de-energized. Then, just to make sure that the tester is still working, again connect it to a circuit that you know is energized. And of course, be certain that the tester you're using is properly rated for the voltage of the equipment you are checking. If there is justification for working on an energized system or piece of equipment as outlined in Occupational Safety and Health Administration guidelines, and it is determined that it is absolutely necessary to work on it hot, you must be sure you're qualified to work on hot equipment in accordance with all OSHA and other applicable technical standards. And make sure that you have and correctly use all the properly tested personal protection and safety equipment necessary. Keep a tight grip on your tools when working. A dropped wrench or other metal tool can create the same type of fault condition you saw in our explosive test events. When installing conductors, refer to equipment wiring diagrams or installation instructions so that the appropriate torque screwdriver or wrench can be used to make sure the wire terminal lugs have been tightened to the specified torque values. Furthermore, know your limitations. As soon as it looks like the work to be performed seems more hazardous than you originally expected, stop and reassess your options. Don't take unnecessary chances. To Square D, safety matters. This video is part of our ongoing effort to remind electricians and maintenance personnel of the dangers of working on or near energized equipment. As another part of this effort, we've made available a fusible product safety label. Why? As a reminder to anyone who is servicing electrical equipment that specific actions must be taken in order to operate or perform services on fusible switches in a safe manner. Number 1, never operate a switch with the door open. Number 2, turn off the switch before removing fuses, installing fuses, or making load side connections. Number 3, always use a properly rated voltage sensing device at all line and load side fuse clips to confirm that the switch is off. And number 4, be sure to turn off power supplying the switch before doing any other work on or inside the switch. Take these thoughts to work with you every day. There is significant risk of serious injury anytime work is performed on energized electrical distribution equipment and other electrical equipment of the type found in industrial, commercial, construction, and in many cases, residential settings. Although we have illustrated our points with fusible switches, the same principles hold true for other types of electrical equipment, including those using molded case circuit breakers and other interrupting devices. We've covered a number of important rules in this video program. Abide by these rules. It's a matter of safety. Your safety.